Hello, welcome to the Extraordinary, where we are committed to the relentless pursuit of excellence. If you love tech, you love learning new things, or you just love to skill up, subscribe to the channel so you don't miss any of our content. I apologize sincerely for not posting recently. I've been really busy with work. Today we are going to continue from where we stopped, which is going over Python's standard library, and we are going to be starting from the mathematics library. The math module gives access to the underlying C library functions for floating point arithmetic. Let's take a look at some of them. First, we import the math library here. After doing this import, we can now say print math.cos math.pi divided by 4. If we run this, we get 0.707, so on and so forth. We could also get the logarithm of a number. We can say print math.log 10242. So we're getting the log of 1024 base 2, and that would give us 10. We also have access to the random module, which provides tools for making random selections. So let's import that and take a look at it. Random, and we can print random dot choice of apple, pear, banana. If we run this, we see one of the choices. If we run it again, we should see a different choice. So it gives us a random choice from this list that we passed in. We could also get a random sample. So we do it this way. We say random print random sample. That will pass in a range, say for 100. So what we've essentially said here is give us 10 random items in this range of 0 to 99. And let me comment on this. Sampling without replacement. I'll print this, run it, and we see we get numbers in the range of 0 to 99, and we only get 10 of them like we specified. We could also get a random integer, and how we do that is you can say random dot random, and this would give us a random float from the interval 0.0 to 1.0. Let's take a look at it. So we get 0.63. Let's try again. 0.33 again, 0.88, and that's how it keeps us giving us random values between this range of 0.0 to 1.0. That's for getting floating point numbers. We could also specify to get the random integers. We could say rand range 6. But what this would do is it would give us a random integer, chosen from range 6. And how this works is that we have range 6 will create a range of 0 to 5, and we're going to get a random value from that range of 0 to 5. So let's run this, get 2, run it again, we get 0, run it again, we get 5, run it again, we get 2, and so on and so forth. Next, we see the statistics module, which calculates basic statistical properties like the mean, the median, the variance of numerical data. So let's import that statistics, and I'm going to create a data list here: 2.75, 1.75, 1.25, 0.25, 0.5, 1.25, and 3.5. Now we can say print statistics dot mean of data. Clear this and run it. We get the value. Next, we can take a look at the median. Let me just duplicate this. The median of this is 1.25. We could also see the variance of this data. Variance is 1.37. So that's it for statistics. The SciPy project has many other modules for numerical computations, and that's basically what is used for data engineering, which we are going to get into properly in later episodes. So the next module we have here is our internet access module. There are a number of modules for accessing the internet and processing internet protocols. Two of the simplest are urllib.request for retrieving data from URLs and smtplib for sending email. Let's see an example of retrieving data from the internet. We're going to import from urllib.request, import URL open, and we're going to use our syntax for opening files. Here we say with URL open http world time api.org /API time zone etc utc.txt as response. Now here we'll type for line in response. Line is equal to line.decode. This would convert byte to string. Then we say if line dot starts with date time, print line dot rstrip, as we remove trailing new line. This will help us access this URL online, and we can now read through it and print the content on our system. But there is something that may happen here. We could have an error. There may be a failure in our connection and so on and so forth. So we need to wrap this in a try except so that we can catch any errors that occur. So we say exception as E. We say print something went wrong. I want to say type E So it tells us the type of error that occurred. In a previous episode, we went into details of how to create exceptions, how to handle exceptions. If you did not go through that video, I'm going to include it in the description below so that you can have a refresher. So let's run this. Say something went wrong, URL error. Okay, so I guess my URL was not correct. Let's see, HTTP world time. Yes, my spelling is not correct. World time. So this is why it's very important to wrap internet access operations like this in a try except block. Another thing that we should do here is let's write print connecting, so we know that this has started, right? So one time API, yeah, this should be etc save, and let's run this again. Something went wrong, connection reset error here. So this is another type of error that can occur where we're trying to connect to a URL but our network got disconnected or it got reset. So our try catch statement is actually very, very important to help with these kinds of cases. Let's see if we can get in. Yes, so this went through this time around and we get to see our date and time from this URL. We're going to skip this example, but because it actually needs us to have an SMTP server running, but you have the idea that you can actually use this SMTP lib to send emails over the internet, and later on we'll probably do something similar in a later episode. The next library we are going to look at is the datetime module. The datetime module supplies classes for manipulating dates and times in both simple and complex ways. While date and time arithmetic is supported, the focus of the implementation is on efficient member extraction for output formatting and manipulation. The module also supports objects that are time zone aware. So let's see that, some examples, and let's import, say, from date time, import date now is equal to date.today, and we can say print now. Let's run this and we get to see today's date. Another thing we can do is we can do some string formatting. So we'll say print now dot string format time. We'll say %m dash %d dash %y. Then we'll do %d, %b, uppercase y is a %a on the %d, a of %b, uppercase b, then full stop. And now if we run this, let's comment this out first. If we run this, what do we get? First we get the date, the month coming first, the day second, and the year last. Then we see that, oh, this is wrong. When we update it, this is %b. Let's run this again. So the next, after the date, we get the date, then we get the day followed by the month and the year in full. So you can see 8th of November 2025 is a Saturday on the 8th day of November. So this gives you a handy way to format your date time strings. dates also support calendar arithmetic. So say we define a birthday as date 1964, the month 7th, and the day is 31st. We can say age is equal to now minus birthday, and what we get if we print age dot days, we get the number of days, the difference in days rather. We could also say print you are age dot days old, and we could say print you are maths dot floor age dot days divided by 365 days. This would give us the year you are this years old. Save. And if we run this, okay, there was an error. Oh sorry, I used data instead of date. So let's run this again. Now we see this is the number of days that is the difference between today and this date that we specified. So this is 200, or rather 22,380 days old, and that translates to 61 years. We also have common data archiving and compression formats that are directly supported by modules including zlib, gzip, and so on and so forth. So let's see some examples of data compression and decompression. I'll comment this out first. Data compression. So import zlib. Say s is equal to e. Say which this is a tongue twister. So which has which is wristwatch, len print len of s. What do we get? It's 41. Now let's compress that. Say t is equal to zlib dot compress s, and if we print length of t, we get, yeah, so the original size is 41 bytes, but after compression we get 31 bytes. Now we could also decompress this, what we've compressed. So we can say print, let me comment these ones. Okay, I can leave them in. Print this zlib dot decompress t, and print, can see that we get the same string that we initially compressed, which has which is wristwatch. So that is it for Python standard libraries. We still have some libraries to go over, which we will do in the next episode. If you enjoyed the content, remember to like and subscribe and share with others. I'll see you in the next one. Bye.